Hey folks, Morgan here. So we're on page 8 of the lecture outline, and I'm going to be honest with you. This is not the very most exciting thing that we're going to do this year, but it's a very necessary thing. We're talking about nomenclature. This is how we name compounds. And this entire lecture is based on the handout that I have posted called Nomenclature Simplified. So everything is explained in there also. Okay, so we're going to start off by naming single metal ions. These are ions that come from the left side of the periodic table. And all we have to do is identify the name of the element using the periodic table and add the word ion. So this becomes hydrogen ion. This is magnesium ion. This is aluminum ion, or aluminium if you're British. And this is the sodium ion. And that's how we name metal ions. Okay? Now, if they are transition metal ions, come from that center block of the periodic table that we talked about on page 6, we generally identify their charge by writing a Roman numeral to represent that charge. So copper with a +1 is called the copper 1 ion. And copper with a 2+ is called the copper 2 ion. Iron with a 2+ is called the iron 2 ion. And iron with a 3+ is called the iron 3 ion. It's actually pretty simple because we're telling you the charge right there. Okay, the far right of the periodic table are our nonmetals. We have to do something a little bit different for them just to indicate that they're nonmetals. So we now go to a name ending that is IDE. So instead of calling this the fluorine ion, we call it the fluoride ion. And that's spelled F-L-U-O-R-I-D-E. Fluoride, not flower-eyed. It's not O-U-R. It's fluoride ion. This is called the oxide ion. This is called the nitride ion. Okay. And then this is called the sulfide ion. Okay. Now, when you put ions together, they form what we call binary compounds. Binary meaning they're made up of two parts. You just put the two names together, but we don't use the word ion anymore because they're not charged. This is potassium fluoride. K is potassium, F is fluorine, but it became fluoride because it was the negative. This is sodium chloride. This is magnesium bromide. This is aluminum iodide. Okay. Now, when you have transition metals, we do need to indicate the charges. So we have to do a little bit of detective work here. This is a Br-. We know that from the periodic table. That means this must be a copper with a +1. So the name here is copper 1 bromide. We know our polyatomics. We've been working on those flashcards. So that's SO4 2-. So this is iron 2 sulfate. Because this had to be an Fe with a 2+, because they were in a 1-to-1 ratio. This has got a phosphate in it, a PO4 3-. So that must be a Cr 3+, because they're in a 1-to-1 ratio. So this would be chromium 3 phosphate. Okay. Now, this one, kind of a contrast to this one. This has got two Br minuses, so this must be a Cu 2 plus. So this is copper 2 bromide. Take this apart. We've got SO4 2 minus, but we must have Fe 3 plus. So this one is iron 3 sulfate. Now here, this one must be chromium 2 phosphate. All right. Okay, that's page number 8. We'll jump over to page number 9 now. So there's some polyatomic ions whose names you've been memorizing. You probably recognize some patterns by now. This was called nitrite, and this was called nitrate. When you have an ite and an ate, the ate is always the one that has more oxygens. Then when you've got a lot of them that will have oxygen, this is the nitrate. I'm sorry. This was the chlorate. This was the chlorite. So, when you've got even more oxygens than the chlorate, we call it perchlorate. Per comes from the word hyper, or meaning more, or too much. And this is hypochlorite. The hypo coming from the word meaning below. Okay? Now, hopefully you've got all of these memorized by this point too. He says with a little smirk on his face, so you're probably still working on it, but hopefully. This is chromate. And this has got 2 chromiums, so dichromate. Okay. Now, the NO3 minus, that one is called nitrate. Okay. Nitrate. This is dinitrite. We have a sulfate. We have a hydrogen sulfate. We have a carbonate. Add a hydrogen to it, it gets called hydrogen carbonate. This would be called hydrogen phosphate. There's a pattern here, people. Now, 2 hydrogens, so we call it dihydrogen phosphate. Okay. Now, when we're trying to name binary compounds that have polyatomic ions, all we end up doing, okay, is putting the 2 names together. So, try and get that straight there. Calcium nitrate. Magnesium sulfate. Potassium nitrate. Sodium acetate. Over here, lithium carbonate. Here, sodium hydrogen carbonate. Calcium hydrogen phosphate, and hydrogen perchlorate. Okay, now this takes tons of practice. We're going to do multiple homeworks on this. It will take you time, trust me. It's not going to happen instantly. Pause as necessary. Get caught up. All right. We'll move this on to page number 10. Now, molecular compounds don't have charge, so the only way that we can know the number of atoms present is by using some prefixes. So CO is called carbon monoxide. The mono prefix means just one. We don't ever put it for the first element if it's a mono, but we always put it for the second. This is sulfur dioxide. And this is nitrogen dioxide. You'll notice I didn't say monosulfur because sulfur is the first element. Carbon dioxide. Sulfur trioxide. And dinitrogen pentoxide. Okay. Now, typically, we don't test the naming of acids in this chapter, but I do include it in here because it's nomenclature, so that you have seen it. When you just have simple binary acids, acids of two parts like HF, HBr, this is called hydrofluoric acid. This is called hydrobromic acid. You'll notice it's starting off with hydro for the hydrogen. Then we're taking the root of the second element's name. Fluorine's root is fluoro, and we're letting it end with ic acid. So hydrobromic acid, the bromo comes from the bromine. Okay, hydrosulfuric acid, hydrochloric acid, and hydroiodic. Now, these are what we call the systematic names, the technical names. There are common names for these acids too, but we don't use them. I know when I was a kid, hydrochloric acid was sometimes called muriatic acid when it was sold in swimming pool supply stores. Okay, now oxyacids. When it comes to oxyacids, we look at what the name of the polyatomic ion is, whether it's 8 or ite. So 8s become ic acids, and ites become is acids. So this is sulfuric acid, because that's sulfate, and this is sulfurous acid, because that's from the sulfite ion. This is nitric acid, because it's the nitrate ion, and this is nitrous acid, because it's from the nitrate ion. Bases are much more straightforward. They're just basically binary ionic compounds, so sodium hydroxide, potassium hydroxide, lithium hydroxide, magnesium hydroxide, barium hydroxide, and calcium hydroxide. And pause as necessary so that you can get caught up here. All right, so we're looking at a couple of weeks of practice on this. It's going to take some time. We're going to give you a lot of homework on it because it is something that is really important. It's our language. Okay? All right, this is Morgan signing off.